Now, welcome back for part B of this problem, the maximum tensile stress in the beam. So how are we going to do that? Well, now that we have our eyes, I usually have a couple steps. I'm gonna write them down right here just so we have a road map. So I usually like to go with 1, determine the centroidal axes, and then determine the moments of inertia about y and z. The second step for me is decompose the moment vector along y and z. And so we kind of did it abstractly, but basically what we're doing, I'm going to cancel this just so we have a little bit more room here to think. Here, this is our y-axis. We want to decompose this vector into these two. And I want to remind you that the moment vector is where your thumb of the right finger of the right hand points, but then your fingers curl around it. So don't think that there's a moment happening like it's so hard to do it in 2 dimensions. But just try to picture your fingers going that way. That's where the moment is being applied. All right, so now that we're doing this, we have to remember, what is this? Well, we said earlier this is 70 degrees. So we can decompose this into 15 cosine of 70 degrees. That would be 15 cosine of 70 degrees. And this one would be 15 sine of 70 degrees with the proper units. So now we can say that we've done step 1, we've done step 2, we just kind of have to put the numbers in. So m, the vector that is along the z-axis, that's the mz. And the mz is going to be 15 kilonewtons times the cosine of 70 degrees. And then my, that's going to be the vector that is parallel to the y-axis or along the y-axis, however you want to think. Those are vectors, you can shift them around. That's going to be 15 kilonewtons. I don't know why I wrote kilonewtons. We're in kips. Kips. So let's redo this. 15 times the cosine of 70 degrees, kips times inches, and 15 times the sine of 70 degrees, kips times inches. All right, so let's plug that into the calculator. Let's get some numbers out so we get ahead. Times the cosine of 70 degrees. And so that's going to be 5.13 kips times inches for the top one, and 15 times the sine of 70 degrees. That's going to be 14.1 kips times inches. All right. So now that we have that, number 3 is determine the distance. The distances of the points of interest. The points of interest. Now, they asked us to find the maximum tensile stress. So we could do all of them, and I probably suggest to do that, or we could kind of reason through a couple and exclude a couple. So for example, if we apply along the z-axis, the moment is going to be like this, which means that it's going to be tensile up here for a positive, and we do have a positive. And so it's going to be compressive here. So we can kind of see this is compressive. So E and D will be in compression, and A and B will be in tension for this specific axis. But now we look at the other axis, and we'd have 15 sine of 70. So we'd have a moment about this axis. And so now, which one would be in tension? So if it's about this axis, we'd have a tension here and a compression here. I hope I did this actually. Yeah, don't reason it through. That's not a good idea. Let the math work itself out. So so we have to be consistent with our coordinate system. What is my YA? My YA, that's going to be equal to my YE because they're the same distance from the Z, and that's going to be equal to what? It's going to be equal to 3 inches. What about my YB and YD are going to be the same? YB is going to be equal to YD, and it's going to be negative 3 inches because they're in the negative Y direction. And then we're going to look at Z, and let's see, ZA. And I think I was looking at things wrong. So let me see. Well, no, the Y's are right. Now the Z, this is where you can make some pretty nasty mistakes. So ZA is the distance from the Z axis. Sorry, not the distance along the Z axis. So ZA is going to be equal to ZB. I got to keep my things straight. And that's going to be 3.33 inches divided by 2. And ZD and ZE are going to be also 3.33. Now, one of the two are negative. And A and B are towards see how this is the negative Z axis? So A and B, this is negative, and this is positive. So now that we have these, we can say number 4. What's number 4? Well, we use the superposition principle. The superposition principle. So that's the formula for unsymmetric bending, which is going to be minus mzy over iz plus myz over iy, right? So now this is where I say let's let the math work out. We'll do sigma A first. So we have, what moment do we have? Moment Z is going to be 5.13 kips inches. And then we have what? The distance YA, which is 3 inches. Then what we're going to do is we're going to divide by IZ. And I don't think I told you what, no, I did. I remember I did. Okay, maybe I didn't. So you go to the Appendix E of the book. And if you go to the Appendix E of the book, you'll find that IZ is 22 inches to the 4th. And IY is 1.8 inches to the 4th. Now, it makes sense that this is smaller because there's less mass away from the y-axis than from the z-axis. So that's another way to check yourself. So this is going to be 22 inches to the 4th. And then we're going to have a plus. Then we have the other moment, which is 14.1 kips times inches. And then where's our ZA? ZA is negative 3.33 inches over 2. And then all of that divided by that 1.8 inches to the 4th. Now, since the formula has a similar form for all the points, I'm going to copy and paste to speed up the process just a little bit, but I'll have to change it because the distances do change. So I'll show you that in a second, but let me just, because we have 4 points, so I said rather than reasoning through because I tried and I failed miserably. So this distance is going to be different. Oh, no, not the A one. This distance is going to be different. Distances might be different. This distance as well. This one, and this one. So here it is. The YE. So let's put letters A, B, D, E. The YE we said is 3 inches. The ZE we said is 3.33 inches over 2. The Z, I'm not going over at this point. The ZD is 3.33 inches, 3.33 inches over 2. And the YD is -3 inches. And then we have the YB, which is -3 inches. And the ZB, which is -3.33 over 2. -3.33 over 2 inches. So we do all of that, and now we just plug it into the calculator, and let's see what we get. So 5.13 times 3 divided by 22 plus, you got another fraction, 14.1 times -3.33 over 2 divided by 1.8. So we get a number. Now let's make sure the units are going to be in kips over inches squares. So that's KSI. And so I get -12.34 KSI. -12.34 KSI. Now I'm going to do the same for the other. I just have to change the distances. So for example, I need to change both of them to negative. So one was already negative, but the other one I need to put a negative in front of it, and I get -13.74 KSI. Then we need to do the same, but now we're going to be doing a negative on the first distance, but a positive on that 3.33. So that's going to be a positive now, and I get 12.34 KSI. And then finally the last one, that's going to be probably positive 13.74, but let's just make sure. Control copy, control paste, and I have both positive values. So both positive values, we get 13.74 KSI. Now they asked for tension, and so this is because this is compression, tension. So this is our answer because this is the biggest value that we were able to find. And so this was how to do this problem right here. I hope this was useful. I wish you good luck on your engineering endeavors, and I'll see you next time.